Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
In this problem, a diver jumps straight up from a board 3 meters from the surface of the water. The initial velocity of the diver is 1.8 meters per second. We'll call that positive because it's up. The displacement of the diver is going to be -3 because the diver ends up going in the negative direction. And the acceleration is the acceleration due to gravity, which is negative 9.8 meters per second squared. We're asked to find the velocity of the diver as he reaches the surface of the water. So we'll call that v, that's our v final, and we don't know it. So the one thing we don't know in this problem is time, and we can take advantage of the equation that doesn't have time in it. It's v squared is equal to initial velocity squared plus 2 times the acceleration times the displacement. In this case, it's in the vertical direction, so we call it y. So we don't know v, so let's call that our unknown. 1.8 is our initial velocity. That's squared plus 2 times negative 9.8 meters per second squared times negative 3 meters. So simplifying these numbers, you can do it all on your calculator. 1.8 squared is 3.24. The units are meters squared per second squared. 2 times negative 9.8 times negative 3 is a positive 58.8 meters squared per second squared. And combining these two values, we have 62.04. And that, remember, is v squared. We still have to take the square root of that to get v. So if you plug it in your calculator, take the square root, you get 7.88 meters per second. This problem gave us two significant figures, so we should round that to 7.9. So the first part of the problem has been answered. The second part asks us to calculate how high the diver gets above the surface of the water. What's the highest he ever gets? So, he's jumping off the board, he's going up, and then he's going back down. And we need to find this distance from the water to its highest point. So we can take advantage of the fact that at the top of the projectile, the top of the parabola, the speed is 0. So using that bit of information, we can use the same equation, the v squared equals v naught squared plus 2a times the displacement. We can use that, but call 0 our final velocity. So at the top, the velocity is equal to 0. So if we do 0 squared is equal to 1.8, that's our initial velocity still, plus 2 times negative 9.8 times the displacement, we can solve that for the displacement. So I'm going to move the 1.8 squared to the left-hand side. That's negative 3.24 meters squared per second squared. 2 times 9.8 is 19.6. That's still negative. And that's times multiplied by the displacement. So we need to just divide both sides by negative 19.6. And when you do this, you get an answer of positive 0.165 meters. Now again, this number is measured from the place where the diver started. This is what we've just found from here to here. We need to find how far above the water he is. So we just need to add 3 meters to that because we know that he's 3 meters above the water to start. So his total delta y from the water's edge or the water surface would be 3.165. The problem gave us two significant figures, so we should round to 3.2. And that is the answer.